Hi, I'm Andrew Russell, AMGA Rock and Alpine Guide and SPI Provider Trainer. In this video, we'll demonstrate an example flow of the AMGA single pitch skills scenario used during the SPI exam. We'll provide an overview of the sequence of tasks and clarify the setup for the scenario. There are multiple ways these tasks may be accomplished. This example shows one baseline approach, and candidates may choose to complete some tasks differently depending on terrain and situational factors. For complete details, candidates should refer to the SPI Program Handbook. At the start of the scenario, the candidate selects the equipment needed to build an anchor at the assigned location. Additional equipment may be used to construct the anchor beyond what is required for the remainder of the scenario. Throughout this process, the candidate is responsible for maintaining a secure position at the top of the cliff, including managing their exposure and using appropriate attachment systems. The goal is to establish a high central point and organized working area at the top of the cliff, which will later be adapted as the scenario progresses. Efficiency is expected during anchor construction, which should fall within the time management guidelines outlined in the SPI program proficiencies. This time is not included in the overall scenario time. Once the anchor is complete, the candidate is tethered and prepares the climbing rope, either stacked on a ledge or managed in a lap coil. With the rope prepared and equipment streamlined, the candidate is positioned at the anchor ready to begin. At this stage, excess equipment is removed, leaving only what's required for the scenario. At the start of the scenario, the instructor is tethered to the anchor and partnered with the client. The scenario time begins as the instructor prepares the system to lower the client. A lowering system is established using a device that is not mechanically assisted braking. A check between the instructor and the client helps confirm the system before lowering. The focus is on managing the system and the client rather than acting out a full teaching scenario. Communication should remain clear and appropriate to guide the task. The client is then brought towards the edge and assisted through the edge transition. Once at the edge, the client is lowered to the ground. Clear communication throughout the scenario is supported by how the instructor positions themselves to see and communicate effectively with the client. During the scenario, the client may move away from the edge when off belay, both at the top and at the base. The instructor then belays the client up the route using a device of their choice. In this example, the instructor is using a Petzl Grigri, which incorporates assisted braking technology, but is not a hands-free device. Taking a moment to break down and clean up the previous system helps maintain an organized and efficient workspace. While the full system check is not shown here, system checks remain an important part of the process, helping identify issues such as improperly loaded devices or unlocked carabiners before continuing. While belaying, the instructor will need to provide assistance for the client. In the scenario, the instructor will be expected to raise the client using a 3-to-1 mechanical advantage system. Here, the instructor takes time to position the friction hitch low on the rope, maximizing efficiency and reducing the number of resets needed during the raise. Throughout the process, the instructor maintains control of the brake strand. After raising the client a minimum of 1 meter, the system is then adapted to a 3-to-1 assisted raise, allowing the client to be raised further. As the system is adapted, care is taken to manage the carabiner and rope as they are extended towards the client without striking the client. There are multiple ways to set up this system, and in this example, the client is able to assist with the raise. Once the assistance is complete, the client resumes climbing. Managing the brake strand during these transitions, particularly with a large loop of rope in play, remains important. At the top of the route, the client transitions over the edge and moves to a secure position away from it. In this step, the instructor sets up and manages a belayed releasable rappel. Ideally, the terrain selected for this scenario allows the client to position themselves away from the edge, minimizing the need to remain continuously tethered. As the instructor builds the tied-off munter belay back up to the rappel, they model a deliberate system check, visually and physically confirming that all components are correctly configured, secured, and ready for use. Here, the instructor frees up the other end of the climbing rope by transitioning to the static rigging rope. This setup will later facilitate a smooth edge transition for the instructor's rappel. By utilizing a gree-gree, this functions as an adjustable full-strength tether, allowing for efficient positioning at the edge. This process requires careful rigging in a clean, organized working space to minimize twists and maintain system clarity. When setting up the rappel, the instructor is also modeling the use of a stopper knot, and all lowers and rappels should be closed throughout the scenario. Ensuring the end is on the ground, the instructor is able to secure the rappel strand to the anchor. Notice that they've deliberately rigged the rappel strand outside and underneath the belay strand. They've also extended the belay munter with enchained locking carabiners to keep the two munters from binding together. Taking the time to restack the rope as needed helps ensure smooth system execution. During the belayed releasable rappel setup, the instructor has access to the client's belay device and locking carabiner, which are included within the allowed equipment list. After a final systems check, the instructor puts the system into action. During the actual rappel, this is not intended to be a full teaching scenario. The client is assumed to know how to rappel, so time should not be spent on basic instruction. Instead, the instructor should focus on clear, concise coaching, including direction of travel, positioning, and pace. While not shown in this video, the examiner will tie a knot to simulate a stuck device. Once the client rappels into this obstruction, the instructor must perform a load transfer to allow the client to clear the issue. The belayed releasable rappel, shown here, is one effective way to manage a rappel, but there are many approaches an instructor may use depending on program objectives, client experience, and terrain. This system represents a primary method we assess for instructor competence, but it does not exclude the use of other appropriate techniques. There are many reasons a device may become stuck, and while this is an important skill for an instructor to manage, effective site selection, clear coaching, and anticipation can often prevent this issue altogether. Once the load has been successfully transferred and the device cleared, the examiner will determine whether the client is lowered or continues rappelling. Candidates should be prepared to demonstrate either method. After the client has successfully rappelled to the ground, the instructor confirms they are in a secure position and can come off belay. This moment reinforces clear communication and marks the transition into the next phase of the system. From here, the instructor begins transitioning the setup into a base managed top rope. This shift allows the instructor to move from managing the system above to supervising and instructing from below. As part of this transition, the anchor is extended over the edge using excess static rigging rope. The goal is to create a cleaner rope path, reducing friction over the lip and improve overall system efficiency. There are multiple ways to build this extension. In this example, the instructor uses a 3-in-1 anchor system to create a redundant central point. What matters most is that the system is intentional, efficient, and appropriate for the terrain and task. Throughout this process, the instructor keeps the system organized, arranging rope, stance, and components to support efficient movement and smooth transitions. Once the anchor is configured, the instructor prepares their extended rappel with a third-hand backup. There are different points at which this can be done. In this case, the rappel is rigged before moving over the edge, as the position at the lower central point would be more exposed and less comfortable to work from. Rigging in advance allows the instructor to build the system while still in a stable stance and adds efficiency to the transition. A clear visual and tactile check ensures that all components are correctly set and ready to be loaded. As the instructor moves over the edge on the gree-gree, they manage the transition in a deliberate and balanced way, maintaining stability while smoothly transferring onto the climbing rope. Before fully committing, the instructor weighs the new system to confirm that everything is functioning as expected. This initial load helps verify the integrity of the setup before transitioning from one system to the next. With the system confirmed, the instructor commits to the rappel and descends to the ground with steady, consistent movement. This final phase completes the transition from a top-managed to base-managed system and positions the instructor to continue managing the site effectively from below. With both the instructor and client on the ground and disconnected from the system, the scenario is complete.